The binary search tree implementation is almost done, so let's check one final thing, that is any memory leakage issue. So here as a variable t1 is defined, and then as we insert the data there, and then what if the t1 variable dies without erasing any data? As you can see in BST implementation, the insert operation allocates a new node dynamically. So at this moment, 5 times new node memory allocation is done. So if a variable t1 dies, then those dynamically created node structures are not freed. So we have a memory leakage issue. To visually show that problem, let me change in node class definition a little bit. So here, let's put destructor as well, and then as a constructor and destruct is called, let's print the message. So new operation is there, and then the node object created at this moment by the constructor, the address is saved in keyword this there, so you can see the address being allocated. Similarly, when destructor of the node is called, so let's print message delete of the memory at this location is performed. So let's compile the program to test the code. As I run it, as you can see, I have created 5 nodes by this loop. But even if variable t1 dies, we do not free the memory. So there is a memory leakage issue. So to take care of this memory leakage, we should implement the destructor of a binary search tree, where when a variable of a BS tree dies, if the BS tree is not empty, we need to free all the memory as nodes are holding the data. So that has to be implemented. So in BS tree implementation, so let's give a destructor there, and then implementation of a binary search tree. Now let's give a destructor there. If you recall, destructor of stack queue and list, we had one of the pop function or remove function that does very quickly regardless of the number of the data in the data structure. Like a pop of a stack or queue is the operation execution time is not dependent upon how many data are already there, since it always removes the very closest ones, top of the stack or front. But in binary search tree, we don't have such. So if we implement one of the naive way to do so, we have access to the root data directly. So what you could do is while root p is not null, still something is there, then we could do something like that. Erase the function, whatever data is at the root, excuse me, just erase it. So that would be one of the naive or simplest way to take care of the problem. So if we compile and then run it, so we see that as we do 5 news, then each of those are freed by the destructor of the node class. So using this one, we achieve the memory leakage problem solved. But here the problem is erase a function. As you remember how it was implemented, if you remove from root, then very complex operation happens. So we have root in the left subtree, and write the subtree. If by the time root binary search tree variable dies, suppose it has lots of data there, then if you erase the root, since it has both left and right, the erase function is implemented such that we find the smallest data from right subtree and then copy the data here and then free memory this one. So we keep doing so. So that is some complex operation we do every time we remove from the root. So this may not be very efficient implementation of a destructor if the node about to die has the binary search tree about to die has many data in there. So another way of doing so, more efficient implementation would be, which is not very dependent upon number of data, just to go through each node once. Then that idea is a traverse breadth function we have implemented and used. So traverse breadth function just go by layer once, and it scans through all the nodes in the tree, and then it does whatever it needed. So we could use these algorithms as we scan through each node just to free the memory allocated there. So here, let's copy the code for this function, and then let's paste it on binary search tree destructor, and then modify the program. If root is null, then just do nothing. That's all. We don't need to do anything at all. But as we find a node, so begin with a root node pushed, and then find its children and then push it. So here we have the first one, so we don't need to display any message. If left of the root is not null, push it. Otherwise, do nothing. It's right is not null and push it, and then that's it. Then when we get the address of a root, we remove from the queue, but its children are pushed, then we can safely delete the node we have memory allocated for the node. It's just we do keep repeating that using the queue. So we just use the same algorithm we used from traverse breadth function, and then use that to free the memory. The code itself is complex than previous implementation, but in terms of execution, since this just scans through all the nodes layer by layer once, it's a more efficient algorithm. So if we compile the program and then test it, as you can see, we get the same result. The 5 news are there. Each of those are freed. So we just avoided any memory leakage issue by implementing destructor of a binary search tree.